welcome. Today we're gonna be talking about ZTF J23 342. It's got a lot more, but that's unnecessary. So this star was pretty much found by ZTF, which is Zwicky Transient Facility, and this facility pretty much scans the skies at night, and it's located in San Diego. This star is located 1,000 light years away, and it's like roughly Earth-sized. White dwarfs seem to be around the size of Earth, but the mass is ridiculous. The thing with this star is one of the reasons why it was located was because the shine that it emits seems to cause different revolutions in light. So it's like flickering of a light bulb to dumb it down. So pretty much when they seen this flickering, they didn't know if it was something orbiting the star, or they didn't really understand what it was, the dimming. But understanding that this star is actually two-faced, that actually gives you all you need to know. One side hydrogen, one side helium. Naturally, how white dwarfs be working in this case is the heavier elements be at the bottom and then lighter elements be at the top. So you would have the hydrogen at the top and then you would have helium at the bottom. But when it reaches about 30,000 degrees Celsius, then the hydrogen and the helium start to mix, and then you get a different type of composite structure. But once like I say, you reach that threshold and they start to mix, that's kind of the next phase. But in this case, scientists believe that it's an asymmetric magnetic field that's causing this state to kind of be hindered. So it's like I guess one side of the magnetic field is stronger than the other, so it's kind of postponing this process. Now this is kind of interesting in itself because this is one of the first times that this has kind of been seen, just kind of one side grainy, one side shiny. It's kind of cool. Our sun is, one side would look more like our sun. Our sun has that grainy look to it. But pretty much for what a white dwarf is, white dwarfs are pretty much small stars that have been pretty much gone through a long evolutionary process. Like our sun will expand to a certain size. Once it burns its fuel, it will explode and deposit its outer shells into the rest of the solar system's inhabitants, and it will be quite an event. And pretty much whenever the outer shell gets burnt off, we'll see. One of the things, we got to see what happens to Jupiter when that happens. By that time we should be, like I say, we should be a trinary star system, quaternary star system. You see what I'm saying? Pentanary star system. We should not be playing no games. The amount of material that gets exhausted creates a planetary nebula, and then once that planetary nebula is created, then you just have a white dwarf that's burning at about like 100,000 degrees Kelvin, and the white dwarf roughly burns for a good billion or so years. They haven't really seen a dead white dwarf, but they burn for billions of years, and pretty much when they're burning, they could only really kind of increase their heat if they go through certain areas in the Milky Way galaxy, or if they actually consume stars. So it's about the material, you see what I'm saying, the exotic material that it needs. But pretty much one of the other reasons why you're able to find or see these type of stars is because they emit a certain type of light. Now the light that they emit is a soft X-ray and something called extreme ultraviolet. So pretty much you already know the life over there is you already know they see like insects. You see what I'm saying? Like that shit crazy. Like even when that happens over here and the shit's evolved to the max, like it's gonna be fucking crazy. I don't know obviously we probably won't be here and whatnot, but just the thought of is immense in itself. But for a white dwarf, not this process does not happen for all white dwarfs. This helium, star, hydrogen process does not happen for every single white dwarf. It only happens for, a primary selective few. And they hypothesize that within a white dwarf's crust, 50 kilometers within its atmosphere, underneath the crust is a crystalline lattice carbon oxygen kind of structure. And this crystalline carbon lattice structure is kind of in resemblance to in resemblance to diamond. So it's kind of like they believe it's an exotic diamond material. It's really unknown, but pretty much that's what you get when you're dealing with exotic type of stars. Once again, this white dwarf, kind of interesting, being two-faced, flickering like a little light switch. But it's kind of cool to see something like this. It just shows like what else is there. Three-phase. Is like, let's be serious. Like, now you just see, that's what happens though. You just opening doors now. Like this, because once we find out the reason for this being the whatever is causing this, we can see if this can cause other happenings too. You see what I'm saying? Like, understanding, is it like the temperature plus the magnetics plus the spin plus, you see what I'm saying? How many variants go into it to cause something like this to happen? You see what I'm saying? And maybe you can do, or not really do it yourself, or maybe you can see what influence this has, because I'm pretty sure this has to have a pretty interesting influence frequency-wise, magnetics-wise, all around. It's the spectrum that you're emitting at the end of the day. Appreciate y'all. See y'all next.